Thank you for visiting our poster on measuring T2 relaxation time in the developing fetal brain. This work was performed by Sir Java Bhattacharya and is presented by Maria Depres. Fetal brain undergoes rapid development during second half of the pregnancy. Changing shape and tissue properties can be observed on fetal MRI. In this work, we propose methodology to measure T2 relaxation time in the fetal brain to measure these changes. Here you can see the changing mean T2 star, a related measure to T2 relaxation time. The black curve represents normal development, while red curve shows lower T2 star values in fetuses that go on to deliver preterm. So far, no such tool has been developed to measure T2 relaxation time in fetus. During MRI acquisition, fetus is moving and mother is breathing. We therefore acquire one slice at a time, and this freezes motion in time. Here you can see an example of the most common T2-weighted fetal acquisition, a stack of 2D haze slices. We can see that we have nice 2D slices, but through plane, the volume is corrupted by motion. To obtain 3D fetal MRI, we first acquire stacks of slices in different orientations, and then we register them as volumes. The registered slices are then reconstructed into 3D consistent volume using super-resolution technique. To refine the motion estimation, we register each slice to the reconstructed volume separately and iterate this process. We have proposed a solution for reconstructing motion-corrected T2 maps of the fetal brain in our previous work. We acquire 9 stacks of overlapping haze slices with 3 different echo times, each echo time in all 3 orientations. In the second step, we reconstruct the motion-corrected volume for each echo time separately. In the third step, we perform dictionary fitting to reconstruct the 3D quantitative T2 map from 3D images for individual echo times. These volumes are aligned together using rigid registration to ensure anatomical consistency. The disadvantage of our previous approach is that it reconstructs volumes for different echo times separately. As a result, we require enough data for good quality reconstruction for each individual echo time. There is also potential for anatomical inconsistencies between reconstructed volumes for different echo times. In this abstract, we therefore propose a joint reconstruction of all data with all different echo times. We input stacks with all different echo times to the algorithm at the same time. Then we perform histogram matching to obtain similar contrast in all stacks. This is followed by slice-to-volume registration and reconstruction in 3D. This way, motion is consistently corrected in all data. In the last iteration, we perform super-resolution reconstruction for each echo time separately and using original intensities before histogram matching. We calculate the T2 maps the same way as in our previous work. To assess whether joint reconstruction improves the accuracy of the reconstructed T2 maps, we simulated motion-corrupted fetal brain data using our modified Fabian simulator. We simulated 3 different levels of motion: minor, moderate, and significant. We compared ground truth and reconstructed maps of separate and joint reconstructions by calculating root mean squared error. When all 9 stacks are used for reconstruction, joint reconstruction improves the accuracy of T2 map only for the level 3 motion, as you can see here and here and here. Visually, the maps look similar. When we select 6 stacks, quantitative improvement is still observed primarily for a higher level of motion. Visually, we can see that the cortex is better reconstructed using joint reconstruction compared to the separate reconstruction. For 3 stacks, we observe quantitative improvement for levels 2 and 3 motion, as you can see here, here, and here. And also clear visual improvement, so this is joint reconstruction and separate reconstruction. We would still recommend using 6 stacks though to obtain good quality maps. Here you can see examples of joint and separate reconstruction on real fetal data with 9 stacks. Results are quite similar but not identical. We are not able to measure improvement due to lack of ground truth T2 maps for fetal brain data. The reconstruction code is available from our website. Thank you for your attention.